Welcome to the deep dive. This week, we're diving into a really interesting set of sources. They're curated by the Pythonist programmer, our software engineering consultant friend, and she's been seeing these incredible connections in some recent reports she found. They're all about how complex systems, and this could be AI, or fascinatingly, even the human body, how they deal with context and connection.
Yeah, how they integrate, or sometimes, well, how they fail to integrate with their environment.
Exactly. It's about that fit.
Right. And what's really compelling, and I think what caught our eye, is how these sources, which seem quite different on the surface, actually reveal these sort of universal principles.
Okay.
We're going to see very similar challenges pop up when it comes to building trust, achieving function, whether it's, code writing AI or our own biology. It really throws a spotlight on what happens when a system isn't quite aligned.
With its surroundings or its own internal wiring, so to speak.
Yeah, precisely. It's more than just tech. It touches on these fundamental ideas of interaction, information, and how crucial the environment is.
Okay, so let's get into this. Our first source, the 2025 State of AI Code Quality Report from Quoto. And right away, it feels like it's shifting the conversation about AI in coding.
It really is.
It's saying, look, it's not just about the volume of code anymore. The new benchmark is developer confidence in that code. That feels like a pretty big deal.
It's a huge shift.
Yeah.
Because the adoption numbers, they're massive. You've got 82% of developers using these tools daily or weekly.
Wow. 82% daily or weekly?
Yeah, and 59% are using 3 or more different tools. So it's not just one thing they're dabbling in.
Right. Deeply embedded.
Totally. And they're seeing benefits. 78% report productivity gains. 57% even say their jobs are more enjoyable. Plus 65% say AI touches at least a quarter of their code base.
Okay, so it's everywhere people feel more productive.
Yeah.
But there's a but coming. I feel it.
There is. Despite all that, the report says, and this is a direct quote essentially, deep trust in their output remains elusive. There's this persistent trust deficit.
And why is that? What's driving that lack of trust?
Well, it boils down to what developers really want versus what they're often getting. They want suggestions that understand the context, that follow the team's coding conventions, that ideally come with tests.
Right, not just code that technically runs, but code that fits.
Exactly. Which brings us to this hallucination problem.
Ah, yes. Heard about this.
The report found that a quarter of developers estimate that 1 in 5 AI suggestions has errors. Misleading code, factual mistakes.
1 in 5. That's
Yep.
That's pretty high if you're trying to rely on it. 20% inaccuracy.
It is. Imagine a teammate giving you feedback, and 20% of the time it's just wrong. You double-check everything, right?
Absolutely. You wouldn't just merge it.
And that leads straight to the core issue highlighted again and again in the report, context.
I check it. Okay.
A huge number. 65% of developers using AI for refactoring, and about 60% using it for things like testing or code reviews. They explicitly say the AI misses relevant context.
So it doesn't understand the rest of the project.
Precisely. It's generating code in a vacuum. And look, even the developers who like the AI's quality, 53% of them still say improving context is the top priority.
Wow.
And for those who think AI actually makes quality worse, 44% blame missing context. It's the #1 thing developers want fixed. 26% of all votes went to improved contextual understanding.
That's a clear message.
It really is. And if you add in customization to team standards, it jumps to nearly 30%.
Yeah.
Developers need the AI to understand their specific world.
The report talks about this confidence flywheel, doesn't it? Sort of the ideal state.
Yeah, it's a great visual. The idea is you get accurate, context-aware suggestions.
Right.
Developers see the quality improve, their trust goes up.
Right.
They merge code faster, and that merged code provides more context back to the AI. It's this positive feedback loop.
Self-reinforcing. Makes sense.
But the reality, the report shows this stark confidence hallucination divide.
Oh?
Yeah. Over 3/4 of developers, 76.4%, are stuck in what they call the high hallucinations, low confidence quadrant.
Oof. That sounds like the worst place to be. Lots of errors, no trust.
Exactly. It's a huge drag on ROI. People are using the tools, they see the potential, but they just don't trust the output enough.
So they're constantly reviewing, fixing.
Right. Manual checks, delayed merges. It eats away at those productivity gains AI is supposed to deliver. Only a tiny fraction, 3.8%, are in the sweet spot. Low hallucinations, high confidence.
Just 3.8%? That's sobering.
It really highlights the gap.
And the report makes this point that accuracy isn't enough. It's not just about whether the code technically works in isolation.
No, not at all. Developers need code that fits the project's context, matches the team's style guide, follows their conventions, and ideally comes with automated checks or tests.
So without all that, even if the code is technically correct, it just feels risky.
Right, it feels foreign, like getting a perfectly engineered part but for the wrong machine.
Yeah.
Useless in context, potentially even harmful if you try to force it. So developers hesitate, they rewrite, they reject.
Okay, so this deep need for context, for trust, for tools that really understand the environment, it leads us nicely into our next source. This one's called A Practical Guide to Building Agents.
Agents?
This feels like the next step, right? Trying to build AI tools that can handle that context better. The guide defines agents as systems that can kind of accomplish tasks on their own, using LLMs for the thinking part, and accessing external tools.
Yeah, it's about giving the AI more autonomy, but crucially, also the ability to gather the context it needs. Instead of just generating text, it can act, query a database, check a file, send an email.
So when does it make sense to build one of these agents? When is it better than, say, just a regular program?
Well, the guide suggests agents really shine when you have workflows with complex decisions, maybe rules that are really hard to pin down and maintain, or where you're dealing with lots of messy, unstructured data. Think of it like, if you can write a simple flowchart for the task, maybe you don't need an agent. But if it requires judgment, adaptation, pulling information from different places, that's where an agent, powered by an LLM, can potentially outperform traditional methods.
Makes sense. And the guide breaks down the core parts of an agent.
Yep, three main things. First, the model, that's the LLM, the brain doing the reasoning.
Got it.
Second, the tools. These are functions or APIs the agent can call. Think of them as its hands and eyes, ways to interact with the outside world or get specific information. Could be searching a database, using a calculator, even calling another AI.
Okay. Model, tools.
And third, the instructions. These are the explicit guidelines you give the agent. Its goal, its constraints, how it should behave, like its mission statement or rules of engagement.
Model, tools, instructions. Okay. And how do these things work together, the orchestration?
Right. The guide mentions a couple of patterns. You could have a single agent that just gets equipped with more and more tools. Simpler to manage? Maybe. Or you can have multi-agent systems. Two main flavors there. One is the manager pattern, where you have a central agent coordinating specialized agents, like a boss delegating tasks.
Okay.
The other is decentralized, where agents are more like peers and can hand off tasks to each other directly based on who's best suited. Less central control, maybe more flexible for certain things.
Interesting. But with these agents acting more autonomously, potentially taking actions, safety becomes a big concern, right?
Absolutely critical. And that's where the concept of guardrails comes in. The guide emphasizes these heavily.
Guardrails, like safety nets.
Exactly. Layered defenses to keep the agent on track, operating safely and predictably within the boundaries you set.
What kinds of guardrails are we talking about?
All sorts. Things like relevance classifiers, making sure the agent stays on topic.
Yeah.
Safety classifiers to catch problematic inputs, like people trying to jailbreak the AI.
Right, trying to trick it.
Yeah. Also, filters for PII, personally identifiable information. You don't want that leaking out. Moderation for harmful content. Safeguards around the tools themselves, maybe rating certain actions as high risk. Block lists for specific words or sites. Output validation to check the format.
That's quite a list. It sounds like building trust in agents requires building robust safety mechanisms.
Definitely. And the guide stresses that even with all these automated checks, human oversight is still a critical safeguard, especially early on. You need humans in the loop to spot failures, review high-risk actions, and provide that feedback to improve the system. Trust isn't just built by the AI, it's built through this whole system, including the human element.
Okay, so we've gone from developer trust in AI code to building more autonomous, context-aware agents with guardrails. Now, we're going to take a pretty sharp turn. This is where the Pythonist programmer's curation gets really fascinating, I think.
Connecting the dots.
We're shifting from AI systems to another incredibly complex system, the human nervous system. Our final source is titled Autism plus Chronic Full-Body-Mind Health Concerns. It seems completely different, but let's see.
It does seem different, but the core theme of system interaction with environment is surprisingly relevant. This document talks about autism primarily through the lens of wiring differences in how information is processed.
Okay, wiring differences, not deficit, but difference.
Exactly. It reframes it, and it dives into specific biological correlates, things like dual processing theory, how sensory input might be processed differently, distinct cellular stress responses, even potential links to mitochondrial function, differences in connective tissue.
Connective tissue like Ehlers-Danlos?
Yeah, increased prevalence is noted.
Yeah.
Also, differences in sleep circuits affecting circadian rhythms and really significant differences in interoception.
Interoception, that's the sense of your own body's internal state.
Right, like sensing hunger, pain, fatigue, emotions. The document suggests this internal sensing can be quite different, maybe more intense, less intense, or harder to interpret for autistic individuals. It's presenting a picture of a nervous system with genuinely different operating parameters.
And the key problem arises, according to this source, when these innate wiring differences encounter what it called environmental mismatch.
Bingo, that's the crucial link. It argues that our typical systems, schools, workplaces, healthcare, social norms, even just the sensory environment like lighting and noise, are often designed for a neurotypical nervous system.
And so they do not align with the needs of a more complex nervous system, as the document puts it.
Precisely. It's not just a minor hassle, it's a fundamental mismatch. Constant friction.
And the consequences. The document links this mismatch directly to chronic stress on the nervous system.
Yes, a cascade effect. It details potential impacts on mental health. Higher rates of anxiety, depression, burnout, trauma as mentioned, alexithymia.
That difficulty naming emotions you mentioned earlier.
Yeah. Sleep problems, insomnia, parasomnias. Even things like ARFED, which is avoidant restrictive food intake disorder, often linked to sensory sensitivities.
And it doesn't stop at mental health, does it? The document links this chronic stress to physical health outcomes, too.
Very strongly. It talks about neuroinflammation, issues with the autonomic nervous system, that's the body's automatic control system. Think dysautonomia, POTS.
Postural orthostatic tachycardia syndrome.
Right. Low vagal tone. And increased susceptibility to autoimmune conditions, maybe even chronic viral stuff like long COVID or reactivated Lyme, things like mast cell activation syndrome, MCAS, histamine issues, gut problems like IBD, fibromyalgia, nutritional deficiencies due to restrictive eating perhaps, and chronic fatigue syndrome.
Wow. It really paints a picture of a system under siege, breaking down on multiple fronts because of that constant environmental stress.
That's the argument, yeah. That the mismatch is the stressor, leading to dysregulation across the board.
And the document also touches on maladaptive coping strategies that can emerge from this.
Right. Things people do to try and survive in that misaligned environment, like excessive masking or camouflaging, basically, constantly suppressing natural autistic traits and performing neurotypicality, which is incredibly draining.
I can only imagine.
Also, increased risk of substance use, disordered eating, attempts to cope that ultimately cause more harm.
And underlying all that, there's this potential for identity confusion or internalized ableism, constantly feeling out of sync with the world, being told implicitly or explicitly that your way of being is wrong.
It takes a toll. It creates this deep internal conflict when your innate wiring clashes so profoundly with external expectations. It undermines your sense of self.
Okay, wow. So AI code quality, AI agents, human neurocomplexity, and chronic illness. We've covered a lot of ground. What's the connection here? What did the Pythonist programmer see linking these seemingly disparate things?
I think the core connection, the multi-layered narrative she saw, is really about the fundamental power of context and environment.
Okay, bring it together for us.
Look at the AI side. The Quoto report screamed it. Trust, accuracy, developer confidence, it all hinges on the AI understanding the specific context. The code base, the team rules, the architecture. Manual context feeding is broken.
Right.
The AI needs persistent learning, autonomous context gathering. Without it, developers reject the code, even if it's technically correct. Why? Because it doesn't fit. A style mismatch alone can destroy trust.
Okay, context is king for AI trust. Now, the human side.
The parallel is uncanny, isn't it? The autism document frames wiring differences, the innate system. But the problems arise dramatically from the environmental mismatch. Neurotypical systems, the environment, create chronic stress because they don't align with that wiring.
So just like the AI code needs to fit the project context.
Humans need their environment to fit their neurological context, their wiring for well-being. The mismatch isn't just annoying, it's physiologically and psychologically damaging, just like bad AI code is damaging to a project's health and a team's velocity.
And the cost of that mismatch is clear in both.
Absolutely. For AI, the report showed low confidence and context gaps are a major drag on AI adoption and ROI. Teams waste time fixing, rejecting, redoing. The potential isn't realized.
And for humans,
The document highlights the significant amounts of energy used in adapting and border coping. That energy drain leads directly to burnout, chronic fatigue, all those health issues we discussed. It's the cost of constantly fighting a misaligned system.
Okay, so context match is crucial, mismatch is costly. What about building trust and function? How does that parallel play out?
Well, with AI, trust comes when suggestions are accurate and relevant, when they follow conventions, when they have checks. And the agent guide emphasized guardrails, those safety features that create predictable, bounded behavior. That's how you build confidence in an autonomous system.
Right, the guardrails provide the safe operating space.
And for humans, while the document didn't use the word guardrails, the implication is there. Supportive environment, accommodations that understand and work with the neurodivergent wiring, those are the necessary structures.
They act like guardrails, reducing the chronic stress, allowing the person to function well, maybe even thrive.
Exactly. They create that state of confidence, maybe psychological safety or peace of mind, that allows the individual system to operate closer to its optimal state. It's the same principle. Align the environment and support structures with the system's actual needs.
So the big takeaway, whether it's silicon or synapses, ignoring the need for context, for alignment between the system and its environment, for appropriate guardrails or support structures, it just leads to breakdown.
Breakdown of trust, breakdown of function, inefficiency, frustration.
Yeah.
It's about designing for the system, understanding its real needs, not forcing it into a box it wasn't built for.
That really lands. It connects things in a way I hadn't considered.
It's a powerful lens, isn't it?
Mm-hmm.
And maybe that's the final thought to leave you with. Consider a complex system in your own life, your team, maybe a project, your family routines, even your own habits. Where are the hidden context gaps? Where are the environmental mismatches that might be causing friction, hindering trust, or draining energy? And what might persistent learning or better guardrails, better understanding, better support structures look like in that domain?
That's a great question to ponder. Thinking about systems through that lens of context and alignment. Thank you for walking us through these connections. Really fascinating stuff brought to us by the Python's programmer this week.
Absolutely. Food for thought.
Indeed. Thanks, everyone, for joining us on the deep dive. We hope this gave you a new perspective. We'll see you next time.